Your brain follows a specific sequence when all social contact disappears. Not a vague decline. A documented, reproducible sequence. The same one observed in prisoners held in solitary confinement, in polar researchers stranded through winter, in sailors lost at sea for months, in volunteers in isolation chambers built for science. The details are unsettling in a particular way, not because the process is rare or reserved for fragile cases, but because it is consistent. The research keeps arriving at the same steps in the same order. The sequence starts faster than almost anyone expects, because your brain was never designed to run without other people. Social contact for your brain is infrastructure, not comfort. Comfort you can do without. Infrastructure, when it fails, takes the whole system down with it. And when social contact disappears entirely, the brain doesn't idle quietly, waiting for input to resume. It starts to collapse in that specific sequence. Threat detection first, then cognitive fragmentation, then the hallucinations, then something that gets at the self itself. And once you know the steps, the idea of being truly alone stops feeling abstract. Here's the thing about your prefrontal cortex. It does a job most people never think about. It constantly filters and interprets sensory data using other people as reference points. When someone smiles at you, when you hear your name called across a room, your brain uses those unremarkable inputs to calibrate its own sense of reality. John Cacioppo, a neuroscientist at the University of Chicago who spent decades mapping the biology of social isolation, documented that when that calibration disappears, the prefrontal cortex doesn't go quiet. It starts working overtime on the wrong problem. It begins scanning for social threat instead of processing social input. The same threat detection circuits built to help your ancestors spot a predator in tall grass activate. And they find no external target to attach to. So they start searching harder. So they attach to everything. Sounds become suspicious. Shadows start carrying meaning. A creak in the wall feels like a warning you don't have the context to decode. This has nothing to do with mental fragility. This is healthy brain architecture running in the wrong environment. Your amygdala was calibrated for a world full of other people. Pull those people out and it keeps firing anyway, because it has no signal telling it the danger has passed. It manufactures the threat it was designed to detect. Cacioppo's research showed that socially isolated individuals demonstrate measurably elevated activation in threat-related neural circuits, even in environments with no objective danger present. And here's where it gets heavier. That elevated threat detection doesn't stay static, it compounds. The longer the isolation, the more the brain reinforces the loop, because the absence of contradicting information prevents the alarm from ever resetting. John Zubek, a psychologist at the University of Manitoba who spent roughly 15 years running controlled sensory deprivation experiments through the 1960s and 70s, found that subjects in prolonged isolation reported cognitive fragmentation, difficulty sequencing thoughts, an inability to hold a single idea before it dissolved, intrusive imagery arriving without any voluntary trigger. His work, compiled in Sensory Deprivation, 15 years of research documented these effects emerging not over months, over days, sometimes over hours. The subjects were not damaged people going in. The environment alone was enough. I want to know in the comments, what's your take on what solitude actually does to your brain? Because the hallucinations are where most people's intuition breaks down completely. The common assumption is that hallucinations in isolation are rare, extreme, reserved for cases of psychiatric fragility. Here's what nobody tells you: the clinical record does not support that assumption at all. Psychiatrist Stuart Grassian from Harvard Medical School studied prisoners held in solitary confinement and documented what he called SAOU syndrome, after the Secure Housing Unit designation used in American prisons. What he found was systematic and reproducible, and disturbing precisely because it was not confined to people with prior psychiatric histories. A substantial proportion of otherwise healthy individuals in strict isolation began experiencing perceptual distortions within days. Visual and auditory hallucinations, hypersensitivity to sound so severe that a distant footstep felt physically painful, and a progressive erosion of the boundary between self and environment. That last part tends to land hard. Your sense of self, the stable internal narrative of "I am a person separate from the world with a continuous identity," depends in part on continuous social feedback to maintain itself. When that feedback stops entirely, the narrative doesn't hold indefinitely. One of Grassian's subjects reported speaking aloud, not to anyone, not expecting any answer, because the sound of his own voice was the only available evidence that he still existed as a distinct thing in the world. The voice is proof of life. That's how far down the sequence can go. The research on extreme isolation consistently reveals a reversal of the expected recovery pattern. The assumption is that once you return to social contact, the brain resets within days. Zubek's long-term follow-up data and Grassian's psychiatric assessments of prisoners leaving solitary confinement point elsewhere. Individuals with prolonged isolation histories showed persistent hypervigilance in social settings. Crowds became overwhelming. Conversation felt threatening. The very stimulation the brain had been starved of now triggered a stress response rather than relief. The isolation had inverted the brain's most fundamental social architecture, and that inversion didn't simply reverse when the door opened. Julianne Holt-Lunstad, a psychologist at Brigham Young University, has spent years building the data on this. Her 2015 meta-analysis in Perspectives on Psychological Science, synthesizing data across hundreds of thousands of individuals, confirmed social isolation as a significant mortality risk factor. Building on her earlier research, which had already put that risk in the same range as smoking 15 cigarettes a day, the mechanism she identified traces directly back to what Cacioppo documented at the neural level: chronic activation of the threat system, sustained inflammation, cardiovascular strain. The biology of isolation scales with the dose, but it starts accumulating long before anyone would call a situation extreme. Stephanie Cacioppo, continuing the research at the University of Chicago, has argued that chronic perceived loneliness, the feeling of being socially invisible even while surrounded by people, activates the same threat detection patterns as physical isolation. The mechanism doesn't require a locked cell. It requires only that your brain stop receiving the social calibration it was built to run on. The relationships you treat as optional may be doing structural work in your brain that only becomes visible when they're gone. Your brain won't file a complaint. It will just quietly begin manufacturing the threat it can no longer find outside. Want more stories like what extreme isolation does to the human brain? Subscribe. That's exactly what we dig into here.